Hi, I'm Eric. I'm a product manager at Google working on Android Auto. And Chris is my co-presenter. He's a quantitative user experience researcher at Google working on the Chrome operating system. We're thrilled to talk to you about and share with you the choicetools package, but before we dive into the details, I want to share some of our motivation, some of the challenges that we faced. Oftentimes in product design, there are a lot of hard trade-offs. It could be that we're building software and we want to know what are the combinations of features that users most want in this product. Or building a piece of hardware and maybe we want to add a part, but that part has a cost, and would we make up that cost by increased sales if we included it? Or it could be in the field of medicine. You may have two drugs that your company could make. One cures the disease better, but has more side effects than the other. Which one should you bring to market? These are the sorts of questions that conjoint analysis can help us answer, and this is part of what motivated us to write the choicetools package. So we have 4 sections to our talk. The first is just the basics of conjoint analysis for product preference. Second, we'll talk about how to create and design such a survey. You can also generate some simulated data. The third is modeling respondents' preferences and then using those models to inform our business decisions. And finally, we'll cover some of the additional features in the package at the end. Okay, so first, basics of conjoint. So the idea here is that you have multiple products or services that you could deliver, and you'd want to know what do users prefer amongst this set of choices you could give them. So imagine, for example, that you're building an automobile. Say it's a minivan, and you have multiple minivans you could build, and you want to know what's the preference of your customer base. So you could create a choice-based conjoint survey and present multiple options to a survey respondent and ask, out of just these 3, which one do you prefer? In this example, we have minivans that have 4 attributes: the number of passengers that they can hold, the size of the cargo area, the type of engine, and so on. And each of those attributes has multiple levels. So for example, 6 passengers or 8 passengers, gas engine or hybrid engine. And so you want to know, well, which combination of these should we deliver? And so you could create such a survey, ask each user multiple such options, ask multiple users, and then start modeling their preferences. So for the rest of this session, we'll go through a slightly different example of a USB flash drive. So you can imagine the flash drive having 5 attributes to consider: brand, style, price, color, and size. And these may have, say, 2 to 5 levels each. For example, color, we have red and blue, and for brand, we have Alpha, Bravo, Charlie, and Delta. Now, just out of this small set of attributes, there are over 600 products you could build. So which one should you build? Well, what we'd like to do is to model users' preference and use that to inform our decision. So the model here is that the probability of a user choosing a particular product, given the attributes of that product, are proportional to their preference for the product. And that preference is in turn proportional to the sum of the preferences for the attributes of that product. So if someone really wants a blue flash drive, then we would expect to see that for all the blue flash drives, all else being equal compared to red ones, they would end up having a higher sum of preference for that attribute, hence a higher preference for those products. So for the next few slides, in practice, things like survey setup, survey design, and gathering data will be done by survey software platforms such as Sawtooth or Qualtrics. But we want to provide an end-to-end example here, and also to be useful for teaching for folks who want to use the package for that purpose. So we're going to create the survey here, simulate data, and then go into the analysis. So in this case, let's say we wanted to survey 400 respondents, ask each of them 12 questions, and in each question we ask them, which of these 3 products would you prefer? Well, but which product should we show them? So we create the design matrix, and our goal is to have a balanced design matrix. What I mean by that is, suppose we look at red and blue as the colors. We would like half of the products that we show to these survey respondents to be red and half of them to be blue, so we get equal feedback on both options. So we have a function that generates this design matrix so that we know then which products to show each survey respondent. So as an example here, you can see that there's 3 different products shown. The first has brand number 2, style number 3, price number 2, and so on. The next step then is we convert that design matrix into a dummy-coded matrix. So we have here then a 1 for brand 2, a 1 for style 3, and a 1 for price 2, corresponding to the products on the previous slide. And then we create the survey. And again, in a production environment, you're likely to use survey authoring software for this. We have functions in the package to do it, so you can either simulate data before you put a survey out in the wild, or for teaching purposes. So we create the survey, and this shows here what the survey may look like. Here's question 1, which we call trial 1, 3 products. So this is brand Bravo, sparkly style, $14. And so on, we ask the respondent, which one of these 3 would you prefer? For the goal then of getting some simulated data, so we can see what might this look like, how could this inform our product design questions, we generate a set of part worths. So the underlying idea here is that each of those levels, like red or blue, or a particular price point, $9, $14, $24, there's a particular value that users have for those. And so we want to model the respondent value for each level. So that's the generate random part worths function. Once we've generated those part worths for our simulated respondents, then the next step is to have them answer the survey, pick the winners, as it were, of each question that we give them. So for that, we have the pick M&L winning cards. That's for multinomial logit, which Chris will go into in a moment. But the idea is that we want our simulated respondents to choose preferred products for each of the tasks that we give them. So in this case, using those same 3 products as in the previous slide, here the simulated respondent chose the 3rd product as the best of these 3, and so we mark that with a 1 in the CBC win field. So at this point, we have a survey, we have a number of products, each of which has a number of attributes and levels that we want to get input on. We have our simulated data. What on earth does this mean? What will we do with this, and how will it help our decision making? For that, I'll have Chris come up and talk about the modeling and how it can help us make better decisions on different product designs.
Cool, thank you, Eric. Yeah, so let's talk briefly about the multinomial logit. Folks have probably seen this in a logit regression before, where we take the utility values for a product, adding up these coefficients, the part worths for each attribute. In this case, for product A, the preference for product A compared to product B is the proportion of preference that product A gets compared to product A plus product B together. This is extensible. If you had many products, each one would have a share of the total preference based on this formula. And I'm omitting some of the math here for intercept and error terms that are under there. Taking our simulated data that Eric showed, which we chose a task based on known part worths, we have perfect recovery. So if we read in that CSV file, and we say our original part worths and then our recovered part worths using an aggregate logit model, we recover the part worths perfectly here. With this, so we have that function. But it's more interesting to collect real data. As mentioned, typically someone would use a survey authoring package for this. In this case, what we're going to do is write out the survey, make some random responses to it, and read it back in here. So we write out this CSV as if you had fielded it in a spreadsheet shared perhaps with students. We read in the choices here. And then what I do is I find the lines in there which says, which product do you prefer, namely your choice for a certain trial that they might have completed. I fill in some random choices here, so the data are random. And I rewrite that CSV, read it back in as if it had been completed. And now we estimate this model, and what we find is random correspondence. Good, so it's working. We write it out, we read it back in, random data. We have no correspondence to the original part worths. Good. Okay. In practice, we would typically use a hierarchical Bayes multi-level model for this. And in the marketing domain, the fixed effects are often known as the upper level, and then the per respondent effects. Because each respondent answers multiple tasks, we can estimate something for each person in this model. Is known as the lower level for those random effects. And so we provide some wrappers around some other utilities in our choice model R in particular that will do this hierarchical Bayes. So we've used this for dozens and dozens of projects in production. over the years. There's some typical options here for Bayesian models using the Monte Carlo Markov chain, how many draws you want to keep, and so forth. I'm not going to go into those, but the package supports those. You can set up here, given your design matrix and given your vector of cards that won, were chosen as the products people preferred, then it starts and runs the UMC process. You can read the individual level preferences here with the function extract HB betas. What we see here is individual number 1 has a strong preference for the sparkly design. Individual number 2 also prefers the sparkling design, but very much dislikes the odd industrial design and so forth. So you can get for each person their preference among these attributes. So now we can know who wants which product if we model this. Additionally, because we know each person, we can plot these. So I'm going to take their individual level attributes. I'm going to melt them by their ID. So we now know for each person their attributes. Plot those, and we get a plot like this. So we can see the distribution of preference for red versus blue, the distribution for alpha versus bravo. But additionally, we can see whether the people are highly consistent, for example, in preferring, I believe it's red up here, where almost everyone prefers that over blue, or if they have a large distribution, such as the degree to which they prefer the $14 price point. So we can see if there are clusters of individuals. These data are randomly generated, but typically you would find that some feature might have a small number who really want it, a large number who are indifferent, or something like that. You can get a sense of that distribution graphically, and of course we can cluster it and do things with those individual estimates. We can also do a market simulation. So suppose we want to compare two products, a flat 64 gig, $9 versus an odd terabyte, $24 flash drive. We simply tell it which columns have those attributes, and then a market simulator has a number of methods for estimating who would prefer this product versus this other product, or among a whole list of them. And we find out in this case, 77% of the respondents in these simulated data would prefer this product number 2. Classroom usage, I suggest to do it just like we did here. Expose the concepts of this. You can create a CSV. I've done this in teaching a class. Share it out to people in a shared Google Sheets doc, for example. Ask them to fill in their choices and estimate it in class. It works very nicely. If you present the results like this, it often leads to very good discussion. Is there anyone here who really hated this attribute or really wanted this? Is anyone's preference not showing up in the distribution? So that's a nice didactic point. There's more on this model in a book that I helped with, which I saw out on the table with Springer, R for Marketing Research. So there's a chapter on doing choice-based conjoint analysis. The package also includes best-worst scaling. Thank you. Best-worst scaling is also known as MaxDiff, where you have an unordered list of things and you're looking at preference and some other features. Got some notes here about which parts of the package are better for kind of classroom use, such as the design matrix versus production use. A couple other pointers. The one I would point out here is some work we've done on creating a product portfolio. If you make 10 products, which 10 should they be instead of just the optimal one? That's it. Thank you. And I think we have time for a question or two.